Welcome back to Caleb the Video Maker 2! This is Caleb from Caleb the Video Maker 2. And this is my second live stream. I did one just last night and it was so thrilling I literally couldn't sleep. So I was like, I gotta do another one. I cannot wait to do another one. So I've been planning what to talk about. I'm still getting into the hang of this, so please bear with me. I'm trying to figure things out. But before we get started, I did want to mention my sponsor, which is IBM DB2, which is a legit world-class database that will literally work for all of your software projects. So go check that out. Link in the description. They are the ones that are helping me produce this content. So make sure we show them the appreciation that they deserve. Thank you. Okay, let's get started. So I got a lot of things I wanted to talk about today, but the main thing I wanted to focus on is computer science and what that means, what it is not, and all that good stuff. So we're going to be going into what kind of job you'd get, what kind of things you should know, and just touch from an overview perspective on a bunch of different pieces of what it means to be in computer science or to be a computer scientist. Now, I am by no means an expert. I'm just going to throw that out up front. Not an expert. But I am studying computer science. That's what I've been doing these videos over for the last few years. And I try to integrate into my videos computer science concepts rather than just programming. And we're going to get a little bit into that distinction and what that means. So, if you are watching this video, I would encourage you, if you have any questions at all, go ahead, leave them in a comment. I'm going to be watching it here. And, yeah, so I got my live chat here, and I can see that people are commenting. I got one person so far. So, leave your comments there, and I will either address them in this video if I find it relevant and I know the answer right on spot, or I will consider that for an upcoming stream, and so forth. Okay, so let's get started. Computer science. Well, that is obviously what I try to focus on in this channel, is being adequate to take a job in the computer science field. Oh, and hey person who commented, I probably can't pronounce your name, so I'm not gonna try. Okay, back on topic. Computer science, what does that mean? How to get a job in that, and what kind of job you're going to be getting. And how is that different than programming? Well, first off, computer science is a science. So what that means is there's some math involved. So if you go into school or like a bachelor's program or maybe even a job in computer science, you should expect there to be some math. If you don't want to do math, then you might want to reconsider doing computer science, because it's a science, and science requires math. So there are alternatives if you are completely against math, but I think if you put your mind to it, you can actually grow to like it. So that's kind of my situation, where I haven't had math in a couple years, 4 or 5 years, and then I jumped into 2 college courses, one on calculus and one on discrete math. And at that point I was like, yeah, I don't really like math. But after you start to do it, you pick up on the conventions and it starts to make a little bit more sense. That being said, I'm still horrible at math, which is why I do programming tutorials and not math tutorials. But there is still a possibility that you can start working with math and then grow to like it, which is kind of what's happening to me, because I've gotten through both of those classes and now I'm in a linear algebra course, and it's like a love-hate relationship. One day I'm like, and then the next day, once I figure something out, I'm like, hey, this really isn't too bad. Makes sense once I know how to do it. And it's the same way with programming. So the same feeling I get programming, I also get when I do math. So don't turn away from math too soon. But that's not the only thing with computer science. There's more to it than just math. So if you don't like math, you can still do it, but there are some things you're going to have to get through, such as linear algebra, discrete math, and calculus. So how does computer science differ from programming? Well, there is a lot of overlap, so it's really hard to say, oh, that's programming, not computer science, or oh, that's computer science, but not programming. It just doesn't work that way. It's because they're overlapped, and parts of computer science is in programming, and parts of programming is in computer science. So what that means is you can be a programmer and a computer scientist. You can't. It's not like one or the other. They can be intertwined. But I would say it's easy to be a programmer and a computer scientist. It's not very easy to be a computer scientist but not a programmer, if that makes any sense at all. So what I mean by that is you can learn programming, you can get a job programming, you can retire programming, but never really get into computer science. But it's a little harder to start computer science, get a job in computer science, and retire in computer science without programming. Like it just doesn't even sound right to me. So inside of a computer science program, there is going to be programming. But if you're programming, it doesn't necessarily mean you're doing computer science. But maybe I'm just making too much of a distinction and it doesn't really matter. That's probably what it is. So when I think programming, I think, learning a programming language, developing apps, and not necessarily caring about the underlying processes of why things work or what's doing what. That's more programming. It's a profession, I guess. I don't know if that's the right word or not, that you can do to make a living. Whereas computer science is, the study of computing. Why do these things work the way they do? How can we make them faster? All of that stuff. So when you get into a computer science program at school, there's some things you should look for to say, hey, is this a good program or is this a big waste of money? There is already a lot of controversy whether going to school for computer science is a good idea at all, and a lot of people will go a different route, such as getting a degree in software engineering or something in IT with a focus on programming or something like that. I'm going the computer science route because that's what I enjoy and that's what I find satisfaction in. But some of the things with computer science is stepping away from the languages and the implementations and learning the paradigms, the methodology, the processes behind the different languages and the different way we do things. That's why in a good computer science program, you're going to have classes on algorithms and things that aren't specifically tied to a language. So as you start moving away from stuff such as algorithms and move towards like classes like Java, you're stepping away from computer science and going more into just applied programming, which is not a bad thing. And I am a firm believer that when you graduate with a computer science degree, you should know how to program. Really good. So there should be a fine balance. But inside of a computer science program, you're also going to get stuff on operating systems, machine language. So we're talking assembly languages, how those work and how those correlate to binary, and how programming languages get turned into that, which we'll talk a little bit about in just a bit. You'll get some on computer engineering, which includes logic gates, flip-flops, small circuits, all that good stuff. But also you're going to learn some of the software engineering concepts, such as software testing, source control, debugging, and all of that. And this is just a high overview. Each one of these topics could be a video in itself, so I can't go in for an hour on each one of these. But if we were just to talk binary, just for example, well, I could talk about binary for hours. I mean, I've made basically series on binary, so these are just some of the main points of what you would want to look for in a computer science program. If you are looking at a computer science program and your class titles are like, oh, Java, HTML, CSS, JavaScript, or I don't know, ARM assembly, for example. Well, those are applications, and the more applications you're taking away from the fundamentals, which will convert into different languages. So if you have a class on programming languages, well, that's going to take a high overview, look at the different types of programming languages, how they work, how they're converted to binary, all that good stuff, and then you can go pick up a language that you need when the time comes. But if you just take a class on Java, for example, and all of your classes are structured that way, you might find the situation where you're almost trapped to this technology stack, which is just all the technologies you've learned, and you don't really understand a lot of the reasons why or what's going on behind the scenes. And that's okay for some people, because if they know how to make an application, they can go ahead and make an application, sell it, make millions of dollars, and they're happy, they're satisfied. That's all they want. But I like to pick things apart to the extent where I'm like, okay, why does this work? So that's why I have gone the computer science route. So some of the other things that are essential for a computer scientist, and a lot of these that I'm going to mention go into the application, because if you just know a bunch of theory, you're going to be completely worthless on the job market. So these are the things you need to start learning, and if your school does not teach them, or if you're trying to study this stuff on your own, you need to make sure you hit all of these points. So when you go looking for a job, you've covered all the bases. I don't know the word. So the first one was math. I talked about that for like 10 minutes, so that's enough math for the day. The next thing I wanted to talk about was managed versus unmanaged code. So you can kind of classify most languages into one of those two groups. So managed code would be, an example would be C#, Java, and unmanaged would be C, C++. And when you say managed, what we're talking about is memory. So when you are coding in this language, are you required to deal with the memory and allocating memory and deallocating the memory? If you are, then you are working with unmanaged code. Because if code is managed, what that means is that all of that memory stuff is going on behind the scenes. You don't have to worry about that. So one of the languages I'm most familiar with is C#, which is a managed language. Very similar to Java if you've worked with Java. Most schools teach Java. That is a great language. Either one are both very good languages, but you should also have experience with an unmanaged language. So that is why I started the C programming series. So the C programming series is just the basics. I haven't even got into really memory management and all that stuff right yet. But learning a language like that allows you to understand what's going on behind the scenes with the managed language. And it actually helps you become a better programmer. For example, in C programming, if you go outside the indexes of an array, you're going to break your program. C# is a little bit more forgiving because, well, you can do simple things like array.length or whatever, and you can manage to protect yourself from those kind of situations. You can also protect yourself from that in C programming. You just got to be a lot more careful. And then when you go back to a managed language, you actually keep those things in mind, and you're better able to protect yourself from software explosions. which we don't want. Okay, so what else? Man, sometimes my illustrations, like I'll listen back to a video I made and I'm just like, oh, did I really have to say the computer explodes? Come on. The next thing that you should probably familiarize yourself with is assembly. So assembly is like the lowest of the low minus programming and ones and zeros. So assembly will basically have a set of commands that you can use to tell the processor to do something. So we have simple commands like adding or subtracting or multiplying, moving from memory to, moving data out of memory, moving data back into memory, all of those little things, and you're very limited on what you can do, but you're still able to do everything that C# could do. It just, you have to go an even extra layer of planning and thinking about how to make this thing work, because writing like a while loop is complicated. Am I saying you need to go learn assembly and write some crazy application? No, I'm not. I'm not saying that at all. I'm just saying you should familiarize yourself with assembly and how it works. Each one of these commands correlates to a string of binary that tells the processor to do something. So we have different sets of assembly language for different types of processors. So there's x86, there's ARM, all kinds of stuff. There's MIPS, MIPS. So each one of those is, if you think about it, is kind of like the programming languages, you know, one might be C, one might be C# or whatever, but we're talking on the assembly level, so they all have their differences because you're working on different hardware. So if you don't know about what machine language is, that's okay. Just go learn about it. Just learn the basics. Okay, what else do I think you should know if you're going to be in computer science? You should know a little bit about operating systems. Now, in the school I'm attending, there is an operating systems class, but I actually haven't taken that class yet. That's one of the upcoming classes that I will be taking. And I'm excited for that because operating systems are extremely important. Now, I'm not saying you need to program an operating system. You got to get that clear. It's like you can't be an expert in everything. So you need to learn the basics of all this stuff and then specialize in one or two things. But what you do need to know about operating systems is that they are the intermediary between your hardware and your software. So if you guys know anything about database design, in one of my database design videos or series, I'll talk about intermediary tables. And these tables kind of go in between two other tables to allow them to have a relationship without things exploding. The same thing works with an operating system. We can write our software to work on a particular operating system, and we don't even have to think much about the hardware. We have to think a little bit about it, but most 95% of all that, probably more, is taken care of. That's because the operating system, once we program to work on that, the operating system itself is going to worry about working on different hardware, using different drivers, all that stuff. So I do have a video on operating systems if you do want to go learn more on that. It's the very, very basics, and that's kind of like the conceptual side of operating systems. You know, what do they do? Oh, well, they're basically an abstraction from the hardware. So we as programmers don't have to program on the hardware. All we got to do is program on the operating system, you know? So that's one thing I think is really, really important. Okay, the next thing is caches, main memory, processors. I know very little on this stuff, unfortunately, but I still know a little bit. So I do think it is important, but you should understand, like, when people say memory, we're talking RAM, the memory on your computer that doesn't stay when you turn your computer off. So that is what's probably one of the most important things with writing software, is you got to be careful to not have memory leaks. And essentially what a memory leak is we're using RAM and we're not letting go of it. So we're just consuming more and more and more and more RAM. And then eventually you're going to run out of RAM, things are going to stop working. You should also know what a cache is, and how a cache is basically sort of like an operating system if you think about it. It's like an intermediary between two layers of the hardware stack. So you can think of like a hard disk, and then on top of that you might have RAM, and then you have the processor. Processor is by far the fastest. And if it needs to get something from memory, well, that's like a really slow process. So the cache is there as an intermediary to store temporarily things that are likely to be used again. So the cache is a way to allow the processor to keep moving without having to hit the RAM. And that's about all I know about caches. So don't ask me questions. Okay, the next thing, object-oriented programming. You'll hear this everywhere. I'm sure you guys have heard of it if you've worked with basically any programming language except C, and yeah, that's basically it, maybe a few others. Oh, okay, so this is a big topic. It's something I could literally make an entire video over, all of the pieces of object-oriented programming. And coming from a computer science perspective, I want to get rid of the language implementations. I just want to think about the core concepts of object-oriented programming that are important to understand when you dive into languages such as C++, C#, Java. All those are going to be object-oriented programming languages. Like I said, there are languages out there that are not object-oriented, so C is one of them. I know there's more out there, but almost all the languages I use are object-oriented. So there's three main pieces of object-oriented programming, and then some people actually have a fourth piece, which I'll also mention briefly. So the first one is encapsulation. So one of the big things we try to do with programming is we like to hide things. And it seems weird, but when we hide things, it makes it easier for us to work with stuff. I mean, imagine if you were driving a car and you had to understand every single piece of that car in order to understand how to drive it. That'd be stupid. I mean, no one could drive a car. So all of the internals of the car is abstracted away, meaning it's hidden. So when things are abstracted, it makes it simple. So encapsulation is similar to abstraction. And basically, we're going to hide complex processes behind very simple public processes. So when you have a class in object-oriented programming, you're going to make an instance of that class, and that's called an object. And that object is going to have properties. So if you think of an object such as a person, that person's going to have a name, Caleb, for example. That name is a property. Well, you could do whatever you wanted behind the scenes inside of that class to make that property work. So often you'll have the property, and then behind the scenes you're going to have a field. And the naming conventions might vary from programming language to programming language, but essentially you're going to make the public property access that field, and the user of that class, so the programmer who's going to be using that class, doesn't usually get access to the field. The only way they can get access to that field is through that public property. So every property is going to have getters and setters. And you can, I guess not every single property, because you can get rid of one or the other to restrict access to that hidden, to that field that's behind the scenes, if that makes any sense at all. So that's kind of like the very basics of encapsulation. Basically, we're going to be able to put a bunch of stuff inside of this bubble And the only thing we really have to worry about is the outside. All the internals, you don't got to worry about any of that. And encapsulation is a pretty interesting topic, so we could probably get into that in a lot of detail. But essentially, just think of the word encapsulate. If you encapsulate something, you're wrapping around it and almost thinking of hiding it. See what I'm saying? Starting to make sense? Okay, good. And that's why I think that's very close to abstraction, which is the fourth one I'll talk about in a little bit. But there's probably some differences. I'll probably have to do some more research because I want to make sure I'm giving some clear definitions and I'm not getting any information incorrect. So I would encourage you as well as extra study to go ahead, do some research on the 4 pieces of object-oriented programming, learn the differences between the 2. Did I say 2? Between the 2? Between the 4. Learn the differences between the 4 because these are very, very common for job interviews because object-oriented programming is extremely important. The next one is inheritance. Inheritance talks about, this one's kind of weird. I don't really know how to give a good explanation without giving probably an overused, annoying illustration. But think of having an animal, right? Well, that's a very broad term, but every animal has some things in common. So let's say we make an animal in our program, an animal class, and we give it some data in there. So we give it the ability to breathe, the ability to die, to come alive. But then what we want to do is we want to make more specific classes. So we're going to make a class on, we're going to make a dog, we're going to make a cat, we're going to make I'm out of animals, a cuttlefish. So you're going to make these animals, and they are going to inherit these abilities from what they call the base class. So I wish I had my screen working. I could show you guys some illustrations, but I'm still trying to figure that out. I haven't had a lot of time to do this because I've been working with my sponsor, IBM DB2. Check them out. They're awesome. But I've been working with them, trying to get these videos planned. So that's why I've been doing these live streams at like 10 o'clock at night because that's the only time I have time. So give me a couple days. I will get the illustrations working, and maybe I'll find a place where I can actually draw on a whiteboard or a chalkboard. And once I upgrade my potato to a potato HD, then I can start making all kinds of illustrations, making them all pretty and stuff. So, okay, that's that one. So we talked about encapsulation, we talked about inheritance, and the next one is polymorphism. And this is pretty similar, but it's a little different. Essentially what polymorphism is that these dogs or these cats or these cuttlefishes can be treated as a dog, cat, or cuttlefish, or they can be treated as an animal, very generally. So if we make some kind of process, a method or function or whatever, that we want to work with dogs only, well then we would need to pass in a dog as an argument. But what if we made a function or method that we wanted to be able to work on any animal? It doesn't matter what kind of animal it is. Well, then we would just pass in an animal. But the thing is, when you say passing in an animal, any class or any object that inherits from animal can be passed in as an argument. So if the function or method takes an animal, you can pass in a dog, you can pass in a cat, you can pass in a cuttlefish. You understand? Yeah. So think of these dogs morphing into an animal. Kind of a dumb example. but when you get into some more concrete examples, it makes sense. So for example, if you are working with an output system, right, and you make a function, and it's like, let's think, write output, and you pass in what you want to write this output to. That makes sense. So you could pass in a file. You could pass in some kind of network stream. You could pass in a database, whatever. It doesn't really matter. Don't think too far into it. Once you pass, when you make that function, instead of making one of the functions take a file stream, making it the same function take a network stream, and making the same exact function taking a database, you can make all of those things you pass in inherit from something they all have in common. So you could make a class like input output, and then all of these other classes could inherit from input output, and then that function you can pass in, you can make the argument of type input output, which means you can pass in anything that inherits from that class. So yeah, it's kind of hard to see all this without illustration, so I apologize. I'm going to try and work that out. How are we going to do that with these live streams? But you can essentially think of a file stream, like writing to a text file. You can think of that morphing into a general input-output, and it works. You can think of the database as morphing into an input-output, and it works. You can think of the network stream morphing into an input-output, and it works. So it makes it easier for the programmer because you only have to write the function one time and take a general version class, a general class that anything that would work can be passed in, rather than making 3 or 4 or 5 functions that do exactly the same thing. Hopefully that makes sense. I don't know. The object-oriented pieces is one of the things that took me the longest to grasp, specifically because I started learning programming with PHP, which I would actually probably advise against, so don't take that as advice. And that was before PHP with object-oriented programming was really a thing. So the book I had didn't touch on object-oriented programming at all with PHP. So when I picked up C#, I was totally confused because it's just a new way of thinking. And by picking up that other language that works a different way, I was able to expand my thinking powers. Yeah. So my thinking power level was like over 9,000. It's pretty intense. So the fourth one is abstraction. And we kind of talked about that with encapsulation. Essentially, abstraction is, you have some crazy thing with tons of information, and we just abstract that away. All you really need to know now is that you have a document. It doesn't matter what's on the other side. Who cares? It's a document. We just abstracted away that information, and we can just treat this as a document. This is very interesting because the word abstraction is so abstract, but we do this literally every day. Everything we do is an abstraction. This laptop, it's an abstraction because we're literally talking to the computer through a keyboard. The internals are encapsulated inside and abstracted away from our needing to know. So how does this come up with programming? Well, obviously with object-oriented programming it's a thing because you can abstract away big complex things. You can make a function, or in object-oriented programming, a function is called a method. You can make a method that's public, meaning you can call it from outside, you can call it outside of that file, but that function or that method can call, 10, 20, whatever other functions and methods that are all private to that class. and we don't have to know a single thing about them. So what that means is if you're doing something very repetitive in your code, you can make that a private method, and then you could call that method inside of your public methods. So I'm trying to think of a good example, but like let's say, yeah, I got nothing, sorry. Hey, at least I'm honest rather than coming up with like some stupid example. Okay, so moving on. Oh wait, another thing I wanted to mention with abstraction. SDKs. They are important. SDK, software. Yeah, that's the word I was looking for, right? Yeah, I think so. Yeah, so a software development kit is, looking it up on Google, I'm just kidding, is a set of software development tools that allow the creation of applications for a certain software package, software framework, hardware platform, computer system, video game console, operating system, or similar development platform. Okay, that totally did not help at all. I'll just put that into English. There's obviously different types of SDKs, I'm sure, but one way that SDKs come up is they basically abstract away something complicated. So, like let's say you're working on an iPhone app or whatever, and to display something on the page, it doesn't have to be an iPhone, just an application, and to display something on the page, it's really super complicated. Well, what you can do is you can make basically a class library, a library that you can access in all of your other files, that abstracts away all that complicated stuff and makes something really super simple like phone.display, parentheses, quote, hey! It just displays on the screen. You don't have to worry about how it works, why it works, or whatever. So that is an example of an abstraction. Very, very common with an SDK, because an SDK is basically a tool set to allow you to make applications without having to know everything. So this is so common. Even in like the .NET framework, for example, you can work with things on your computer without necessarily understanding how everything's working, because it just, it's very simple, like do something, done. If you're working with an API, that comes in handy. So if you don't know what an API is, basically it's a way to get data from websites publicly. Well, some of it's public, not all of it's public. You can authenticate yourself to get private data, but a lot of websites have a public API that you can use to get data. So for example, you can get the Instagram. You can code against that to get data to basically scrape Instagram for information in code. Well, working with an API in code can be pretty complex, so a lot of people will make an API SDK. And essentially that would be like, let's say this Instagram example, you could have a function like person.get photos, and then it just puts those photos into an array, and it's done. That's all you got to do. Actually making the SDK is the hard part, but once you've done that, you have an abstraction in your code that makes it super easy to expand your software system. And also another thing, it's easier to test because you can test that SDK, and if you can verify that it's working, well then you should be able to use that SDK in all of your other software, and it should work as expected, rather than doing all of the coding to get the API information manually each time, because that's very, very error prone. The only time the SDK would break is if the public API changes the data structure or the data types or something like that, which is, it happens, but it's rarer than we really need to worry about. It's just something we have to deal with. So yeah, those are the 4 pieces of object-oriented programming. Sorry I talked about that for 10 hours, but that's okay. So as a review for those ones, I still got some more, so don't go yet. Don't you dare leave. I'm trying to teach you, okay? Encapsulation, inheritance, polymorphism, and abstraction. Yeah. See, abstraction, you know. My abs are hidden away from public. Stupid joke, never mind. Gosh. Okay, moving on. Let's talk about compilers, interpreters. These are things that are important if you are going into computer science and programming. You need to know about these, okay? So learn about them. You don't have to know everything, though. The very first thing you need to know, though, is what in the world is a compiler? Actually, let's not even go to the compiler yet. Let's talk about an interpreter. So you write this crazy application, and an interpreter is going to basically run through your code as it's being executed and execute it at that moment. So essentially what that means is all of your errors and stuff don't show up until you actually run the program and get to that position. This is different than a compiler, which will give you compiling errors. So even with an interpreting language, you can still get some compiling errors, even though they're not really compiling errors. But you might be working with a software that is going to help you find errors. But a true interpreter is not going to notice those errors until it hits them when the application is running. A compiler, though, is going to basically parse your code and find problems. So for example, if you put an extra double quote, it's going to just not compile. You literally can't make the compiled version of your program because you have a compiling error. So that means you can't even execute your code because it's not compiled yet. So there's ups and downsides to each one. Personally, I like compiled languages, but you know, that could always change. A lot of people say that an interpreted language is easier to debug, but I don't really see why that is. I mean, I guess because you don't have to spend time compiling. I don't know. So if you guys have any insight on that, leave it in the comments because I want to be enlightened. So why would you prefer an interpreter over a compiler? Because everything I know, I think, oh, compilers are the way to go. But I am curious to hear from someone who's worked with an interpreter more than a compiler. So I like compilers because it catches a lot of your issues before you even execute your code. So that's good because there's less errors, and all the errors are found before you run the software. If you're in an interpreter, you have to go and find all the endpoints of your software to make sure everything's working. So I don't know how that's better, but both compiling and interpreting languages are extremely popular. So it's not like one outweighs the other. There are a lot of compiling languages and there are a lot of interpreting languages. So I'm sure there are upsides and downsides to both. So what is an example of a compiled language? We're talking C, C++, Java, C#, all those good things. They are compiled and then executed. Now, I'm going to go in a little bit more detail, and it's going to be a little bit specific to C#, but some of this is going to carry over into Java. You know, C++ and C is probably a little bit different, but that's okay. That's because they are, do you remember the word? Unmanaged. Yeah, so C# and Java are managed. We don't have to worry about the memory as much. So let's talk a little bit about how a compiler works with a managed language. And this is like super high level, so this is nothing like a compiler class in school or something. You are going to write your code, and then you're going to click compile. And that is going to check all of your code for any kind of syntax errors, which is when you do something dumb like putting 2 double quotes or something. And it's going to bark at you and say, meh, fix this, meh. Well, then you go fix that, and then once you got no compiling errors, you can compile that code down to another kind of like another step. And in C#, it's called Intermediary Language. And I don't know what Java is, like bytecode or something, I don't know. But basically the same thing. And this is then executed, and there is another process that's executed on this intermediary language using a jitter, J-I-T, just in time. And essentially that's going to run this compiled code just in time for it to be executed. So it's going to compile it down to machine language just in time for it to be executed, if that makes any sense at all. I don't know why I ask if it makes sense, because it's not like you, well, what am I talking about? I'm so not used to doing live streams. I'm not asking you guys if I'm making sense. So please leave a comment. Make sure you explain if I'm making sense. And I am getting your comments, but I'm going to do my teaching, and then I'm going to address any questions and so forth. Yeah. Okay, what else? Yeah, okay, so the jitter is going to compile that to machine language just in time for it to be executed. So there's kind of like a two-step process. And an interpreter is just going to execute it as it goes. An example of an interpreted language is JavaScript. So, yeah, that's all I got. JavaScript. Okay, what else? Okay, this one is probably one of the most important things to know. Yeah, for sure. I didn't put it at the beginning just because I wanted to make sure I was warmed up enough to explain it with enough energy and kind of get into the feel for this live stream. But this is the probably #1 thing on my list of things that you should know before you go looking for a job. Okay? And that thing is, I'll tell you in a couple minutes, because I'm going to save it for last. I'm so mean. Okay, the next one. I got to make sure I don't forget that. The next one is testing. So software testing is so important, so close to #1, but no, it's not #1, because what's the point of testing software if you don't know how to write software? So all the other stuff is kind of important, but testing is extremely, extremely important. So one thing with testing is essentially we're trying to make sure our software works the way it's supposed to work. So we can do a bunch of different types of tests, and one day I'll probably make a live stream dedicated to testing, test-driven development, the different types of tests, unit tests, integration tests, white box testing, all that stuff. So let's talk about that. Okay, so testing, 1, 2, 3. The very first thing with testing that I wanted to talk about is unit tests and integration tests. So a unit test, if you think of a unit, it's like the smallest indivisible piece. So to an extent, we kind of break those rules, but with unit testing, we are trying to test a very small piece of our software to make sure that it does what it's supposed to do. So we're talking like testing a small method to see if it gives the correct output when we put something into that method. So with testing, you generally aim for 100% test coverage. But in a perfect world, this would be possible, but we're not in a perfect world, unfortunately. So what that means is getting 100% test coverage is very, 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 very hard, or very, very, very time consuming, and usually a waste of time, because a lot of it's going to be redundant. So what that means is we strive to get as close as possible to 100% test coverage without writing tons and tons and tons of tests. So we need to find a happy medium, because if we spend, 10, 20, 40 hours a week just writing tests and not writing software, we're going to run out of software to test, which means we're not going to need to test any software, and then we're out of our product. So let's explain what it means for test coverage. When you're working with an application, things break off into pieces. This is, very common with if statements. They are called flow control statements, a way to control the flow of your application. So, think of it like this. All right, so you start here, and then you have an if statement. If it's true, it goes this way. If it's false, it goes this way. Well, then in here, you have another if statement. If it's true, it goes this way, and if it's false, it goes this way. Well, now we have 3 endpoints, 1, 2, and 3. To get 100% test coverage in this situation, what we need to do is we need to write either manually test or write automated test, which we'll talk about maybe, to make sure all of these 3 endpoints do what they're supposed to do. So you'd think, oh, 3 tests, but we actually will probably have more, because different ones may have multiple use cases. For example, this is just a very simple example, but one specific endpoint might have multiple options. Like, for example, what happens if a specific variable is 0? What if a specific variable is positive? And what if a specific variable is negative? That might actually break this point into 3 tests. I cannot draw this way, it's confusing. So, to get 100% test coverage, you'd have to test every single possibility. And that's unrealistic. So instead, what we do is we focused on the edge cases. So edge cases are like pushing your limits, like that mischievous high schooler kid who just wants to try to get in trouble, but not actually get in trouble. Okay, that was me. So you push your limits. Let's say we write a function that accepts the values 0 through infinity. Okay, I lied. This is that high schooler kid who does want to break the rules. Sorry. So we're going to accept positive values from 0 to the maximum for whatever data type. You're going to test the bottom, so 0 or 1, and then you're going to test the absolute maximum, and then test just a little bit after that. So this guy's, he's really pushing his limits and trying to get the system to break. So that's why I changed it. This is the kid who purely just wants to get in trouble for the fun of it. So you're going to test over the edge there and make sure that the software responds correctly. You're also going to test, 0, -1, and if you want, you can test some other negative values, and it just depends on the situation. But the reason we do this is because those are going to cover most of the cases. For example, if you put a 64 and then a 65, most likely it's going to do the same thing, because we're just writing a function that can do the same thing for any positive number. So why would we waste our time doing multiple different numbers when we could just do, 1, 65, and then whatever the max is for that data type. And then the reason we check breaking it is because we want to make sure the software responds in a correct manner if a user breaks it. And a user will break it. Every single bug that you could ever possibly have in your software, a user will find, and they will exploit that bug and destroy your software in your company. Okay, maybe a little bit of a scare tactic, but I'm serious. I don't remember where I heard this, but somewhere I heard that a good programmer is someone who looks both ways when they cross a one-way street. because someday, sometime, somebody will be going the wrong way. Account for that in your software because it's going to happen. So if you put a negative number, make sure the system responds like, hey, this is not valid, you need to change this. If you put 0, do whatever, blah, blah, blah. You can actually automate those things and you can compare values and make sure it's working correctly. So that's what I mean by full test coverage. We want to strive to get full test coverage, and the way we do that is by testing the edge cases right before the limit, and then the limit, and right after the limit. Now, do you want to do those tests automated, or do you want to do them manually? Most of the time you're going to want to do them automated because there is testing frameworks that can do, thousands of tests automatically, and doing that manually would be a big pain in the butt, and that's just stupid. Don't do that. So yeah, automated testing. The cool part though is you can actually tie this to a build server, so you can actually prevent your software from being released until all the unit tests pass, which is cool. And that goes into agile, continuous integration, continuous deployment. We'll get into that another day because I'm tired of talking about that stuff. But that is some cool stuff that maybe once you get all these fundamentals, that would be a good topic to go into. Like how do you do this automated testing with building and releasing software and all that stuff. So the other type of tests are integration tests. These test your entire software as a whole. So this would be something like, hey, this function is supposed to put data into the database. So what we're going to do is we're going to clear the database, try to insert data, and then try to get that data back out to make sure it worked. The reason that is different than a unit test is because this requires your entire system to work. It requires your software to work. It requires the software to be able to communicate to the database and for you to be able to get that data back out of the database. So these are the tests that generally the non-software engineers, the non-software developers are able to write, not in code, but in English. They can say, hey, we need to make sure when we get this data from the database, it works. And what happens if you try to get incorrect data? What happens if you try to run something else? So that is a little bit more complex because it tests your whole system. And the reason non-software engineer people care about this is because they care that the software system works. They don't care if a method works. They probably don't know what a method is. So they want equivalent of what could be English. And in fact, some testing software can make these test cases in English, and then you can tie that to code. So then a tester can go through this and see exactly what things are supposed to do in English. It's pretty cool. I've used software like that. I don't personally like it, but that's because I'm in software, not testing. So that's all I really got for testing. Another thing I did want to mention with testing is if you're interested in computer science, but you're not really very good, go into testing. Yeah, that is some advice a family friend gave me because I'm a noob. And going into testing is a little easier because you still get to work with the software and you get to write tests, which uses the software, and you get to program. But you don't necessarily have to make sure the entire system is working correctly, and you don't have to be very intricate with your programming. It's a good way to get into the system without having to dive right in if you're looking for a job and you're struggling to keep up or whatever. Okay, next thing. Man, this is lots of stuff. We're up to 58 minutes. Wow, that's crazy. Okay. Test-driven development. I thought I was done with testing, but I'm not. Okay, so test-driven development is pretty important. A lot of companies do it. Not every company does it, and some people like it, some people don't like it. But essentially, test-driven development is when you write the tests first, make sure they fail because you haven't wrote the code yet, and then go implement the code to make the tests pass. And essentially what this does is it forces you to construct what your software is supposed to be doing before you program it. Because one of the big problems with programming is the guy who's paying for it wants something, you make them something completely different, and then you have to go back and redo it. So that's what we want to avoid, and one ways of avoiding that is through test-driven development. Get the person who's paying you money to work with you hand in hand in writing these tests, making sure that the coverage is what they want for what the software is supposed to do. Then, as long as those tests pass, everything behind the scenes is basically up to you, assuming you're in a small team. If you're working with tons of software engineers, you probably have to go through some code reviews or whatever else. But once you got that testing, the rule list, like basically, hey, here are the tests that we need to pass to show that the software is working the way it's supposed to be working, you can just basically abstract everything behind those tests away from the customer, and as long as they pass, you're good. So it's a really great way to make some software. Yeah, so the other thing was agile. Controversial. I don't really feel like talking about it right now because my throat's starting to blister. Yeah, so let's go on to the next topic. And that topic is databases. The reality is that we are moving to a data-driven world. I mean, we've been doing that since I was like 10, a couple years ago. So it's nothing new. But every single day there is more focus on data, analytics, machine learning. How do we use this data to make business decisions? Because data has the power to do so much. So there is a lot of databases out there, and they're all very competitive with one another. And if I would highly recommend that you learn at least one database, and I would focus on a structured database because that is like the foundation of databases. Unstructured databases, which I have a video on unstructured data and all database design, so you can learn all about what all that means. But unstructured is not quite the overpowering database implementation. And in fact, there is some problems with unstructured data that it seems, at least right now, that structured data is the only way to really make it work well. So I focus a lot on structured data on my channel. I have a 50-part database design series, all on structured data, how to structure a database. But I don't have a lot on unstructured data because I'm not super convinced that it's as... I gotta be careful how I say this. I think unstructured data is extremely important, but I think structured data is also extremely important. And it seems a lot of people are ditching the unstructured data and then coming up with some serious problems in their software design. There's an article, I'll try to link to it, but I already forget everything I said I was going to link to, so you might just want to look it up. I'm just being honest, it probably is not going to end up in the description because how many YouTubers actually do what they say they're going to put in their description? Like, it's nearly impossible. But there's an article out there on something like why not to use MongoDB, for example, which is an unstructured database. And he has some valid points, or she, I don't know if it was a boy or girl, I don't know. But I think there are some situations when you very well should be using MongoDB or something that does have unstructured data. So if you're new, I would highly, 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 highly recommend DB2 from IBM. And the reason this is because I have been shown some of the things that DB2 does that completely overpowers competitors, and the price tag is a lot better than the competitors. So the bang for your buck is much more. And if you're just learning development, that is a huge marketing point. If you can come to a company and not only do I have programming skills, but I also have big business concepts that can save us money, then that is another marketing standpoint and can actually help promote you into management. So I'm not saying you have to do management, But if you know ways to save your company money, well, then paying you a bunch of money is not really a problem. You know what I'm saying? So DB2 is a database that you can use for free, which is really cool. So the developer edition is free. It has all the capabilities that the full version has. So you can try out all the features. And then you can even start selling your software or whatever with a production version. After that, once you decide, hey, this database rocks, it rocks my socks off, I'm going to be using this, well, then you can shift editions, if that makes any sense. So it's not like you gotta pay tons of money up front to get like Enterprise DB2, because it's really not needed. You can start with a developer edition and then move up to the next edition and the next edition, and it's all the same code base, so switching editions really is not a problem. So one of the things that I like with DB2 is, well, they support non-structured data or unstructured data. And after I was just giving some crap to unstructured data, I do think it is important, and it's definitely something you should know. I've even made some tutorials on unstructured data with DB2 and MongoDB, so it's not like I'm like, oh, don't use unstructured data. I'm saying don't replace structured data with unstructured data. They have two distinct uses, but DB2 supports both structured and unstructured data. So you get the best of both worlds inside of one database. Some of the technology behind DB2 completely blows away the competitors. So one of the things is blue acceleration. Why it's called blue, I don't know, but it's BLU, and essentially this is an in-memory way of running analytics on your data. So it's fit for analytics. They are hoping to come out with some stuff to make the benefit pass on to transactional stuff. So like if you're thinking an online store where you're buying and profiles and all that stuff, that's primarily transactional stuff. So inserting, updating, deleting, all that stuff. Analytics is going to basically look at the columns and run data on the columns. So if you need to have analytic processing, DB2 blue acceleration is incredible. Like, I have a document that compares DB2 with Oracle, and it has some surprising information. It's a couple years old, but I mean, I'm sure not a ton has changed since then. I will try to keep my eyes open for a new article, but so I will try to put that in the description. But essentially, I'm not trying to get off topic. What I'm trying to tell you here is that there is a way to process data both by column and by row. So this is getting a little bit into some of the way databases work. And the important thing to know is that DB2 can be used for a variety of different things, because it can be used easily for analytics, and it can be easily used for transactional based processing, unstructured and structured data. So it's kind of like, it's a database that can get you started, and you can get experience in a bunch of different things, which will ultimately make you more marketable. So please go check them out. Download DB2 Developer Edition. Give it a try. That'll be the best database to start with. So that is all the stuff that I wanted to talk about, except the last one, which I think is by far the most important. And that is source control. All right. So you ought to know how to program before you use source control, but you should be learning source control as you learn to program. So it goes hand in hand, because a lot of people, they'll learn a programming language really well, and then once they're really good at it, they'll pick up source control, and at that point they have to catch up on their source control skills. What do I think about Agile? That is a very good question. I'm going to answer that real quick. I think it can be useful. I don't think it's the only way to write software, because I think it's a little you know, I guess if software had religion, Agile would be the controversial religion that everyone argues about. And like most of the jobs I've worked have done Agile, so I understand it. I know how it works, but it's not the only thing. And I want to get a lot more into Agile once I get my screen sharing working. I'm going to show you guys how Agile works and how to use it, because most software companies use Agile, and it's very important to know. So back to what I was talking about with source control. Source control is essentially a way to centralize your code in a backed up manner. So you don't just have it all on your laptop, but you have it up either in the cloud or you have it on multiple laptops. So the benefit here is that it backs up your software, so when you break everything, because you will break everything, you have that backup. In addition to that, it's easier to work in teams. And if you can't work in a team, you're not going to be able to write software for a company, because literally every company is going to be using source control nowadays. So if you don't know what source control is, that's okay. It's just time to catch up. So the most popular source control system right now is Git, G-I-T. That is the source control management system, or not management, source control system, software, whatever. Git is the source control that I would recommend, and that's because it's a distributed source control system, whereas the competitors are not. So what that means is that you don't necessarily have a centralized server. Most of the times you do have a centralized server, but with Git, what I can do is I can start writing software, and I make a bunch of changes, and I'm like, oh, this is really, really, really great, and I want to make sure I save this, but I don't want to give it to the company yet because it's not quite done. But I don't want to lose this. So what I can do is I can take everything I've done so far, I can save it in a commit, and then I can keep working on my software. And then I can make another commit and then keep working on my software. And then I can make another commit and keep working on my software. Then once I have a piece of software that, is fully functional, or a little section that's fully functional, then I can commit all of those commits at once to a centralized server if I want. The reason I think that is so important is because the competitors, which you should know these too, is Subversion, Team Foundation server on Visual Studio Online. Those are the two main source control software out there. Those are not that way. They're a centralized system. And because they are centralized, what that means is every time you commit, it has to go to a centralized server. So it pressures you, because if you're working on something and it's not quite ready, like you have half-written code and all that stuff, it pressures you to push crappy code to a centralized server, or it pressures you to not push your code to a centralized server, which is even worse, because if you don't push your code to a centralized server regularly, you get the situation where you built so much on your local machine, and the problem is then is you have hundreds of files, or it depends on what you're doing. You might just have tens of files. You have tens of files on your machine, but not on the centralized server, and your commits become extremely large and error prone, because the chances of it not working on your coworker's machine is very high, because there's so many changes, and you might add files, you might remove files, you might change settings, you might change configurations. That's all likely to break. And also, like if your computer explodes, which your computer just always explodes, right? It just has to end that way. That's more likely to be an issue, because now you have more code just sitting on your laptop ready to be destroyed. With a distributed system, it still works the same way, because it's all going to be on your local machine until you commit it to a centralized server. So you still have that risk of your computer exploding and losing it all. But if I go in there, make a couple commits, but I don't push it to the centralized server yet, and then I just happen to screw everything up, everything breaks, well, I can roll back to a previous commit on my local machine to a commit that's not on the centralized server. So there is a much higher chance probability that I can recover from that disastrous event. With a centralized server, you're going to have much more stuff on your machine because you are trying to make a big enough piece to commit it all at once, and it's just much more error prone. I'm not sure if I expressed that the best way, but hopefully that makes sense. The main thing is just decentralized source control is the way to go for your company. So if you start a software project and let's say you're a subversion master, I would say trash that garbage. Okay, get Git and don't go back. You need to use Git. Okay, confession time. Okay, I'm sorry. I use Subversion at work. Don't tell anyone. But I still would prefer to use Git. But everything we do is on Subversion, and I hate it. Okay, so lesson learned, use Git, and if you want to use a centralized server, you can use GitHub, which you've probably heard used GitHub. If you don't have a GitHub profile and you're a programmer, you're probably not going to get a job. Maybe, but get a GitHub profile, and also if you want a private repository, which is where you store your code, check out Bitbucket, Bitbuket. There you can have private repositories and you can invite people so you can still work on it as a team, but you don't necessarily have to pay for Git because their private repositories cost money. Sorry, you don't have to pay for GitHub because their private repositories cost money. Git and GitHub are not the same thing. Git is the source control software that GitHub chooses to use. Hello, Mitch. Welcome to the live stream. Hopefully you enjoy it. Okay, so source control. Learn it now. Don't neglect this. Okay, like I've talked to people who are in software, in computer science, or a programming course, or a program like a 4-year program or whatever, and these programs are not teaching source control for some reason. Fortunately, where I go, they teach source control, they teach testing, they teach all the stuff that's important for actually getting a job, and they teach the computer science stuff behind all that stuff. But a lot of schools, I don't know if they're just behind or what, but they are not teaching the essentials for getting a job in computer science. And maybe they don't think it's their responsibility, and they just want to teach the fundamentals behind everything. But that's a question for an argument. I don't know what my opinion is on that. All I know is that if you are doing anything with software, you absolutely have to be using Git or some sort of source control. With that, it's almost always used on a resume. So if you apply for a job, there's a 90% chance they're going to ask for some kind of code you've written. It's how you get hired. I mean, how are you supposed to get hired as a software intern or software developer, software engineer, or whatever, without any portfolio? I mean, it's your portfolio. You should be writing all of your applications inside of a repository or multiple repositories and get them up on GitHub right now. Okay, and then send them to me, and then if you guys got something cool you want to share, I can maybe share it with the community. So it's a great way to build communities, and it's really, really great. Now, I confess my GitHub profile is pretty pathetic, but that's because I actually use Bitbucket for my school projects. I keep most of them privatized because I don't want to get in trouble for putting solutions to problems on the internet. If that makes any sense. You know, it's kind of borderline academic misconduct, if you ask me. Ooh, I'm thirsty. Okay, so let's say you do go into computer science. What kind of job are you going to get, and what are the earnings like? Well, the job you get is probably going to be something like super boring. I mean, I'm being honest, like I love programming, but working full-time as a programmer is very challenging. Unless you love sitting and you love not moving for like 8 hours. It can be very physically demanding, believe it or not. Very, very likely to have back pain, very likely to have health problems. But it's not all negative. It's very, very rewarding because you get to use your brain. I would rather be using my brain all day than getting paid the same amount to play video games because I actually care about myself and my personal development. So the kind of jobs, there's a couple different jobs. There's software engineer, there's software developer, there's programmer, there's, I don't know, software testing, and they all have their interlaps, and my goal is not to say the difference between a software developer and a software engineer. It's very small, but you're basically going to be doing the same thing for any of the jobs, regardless of what the job description says. The general consensus, or I don't know if that's the right word, the general thing that I've found is that a software developer does the exact same thing as a software engineer, but just gets paid less. Does that make sense? I might be wrong though. Yeah, so the earnings though are extremely high for all of them. Software is one of the highest paying things in existence, and if you're good at it, your value is extremely high. The average is insane. And also you have opportunities that you don't often get other places, like using your brain regularly. You're encouraged to learn, you're encouraged to educate yourself. In some jobs you are actually encouraged to take care of your health, and a lot of software companies will have their own gyms and their own fitness programs or whatever. The earnings, though, are well above average for the national average of earnings, and you can do things such as working remotely, and whether that's a good thing or not, we'll discuss another day. That is actually something I want to dedicate one of these streams to, is how do you work remotely, and how do you do it without dying and hating your job? How do you log your time and do things ethically and all of that good stuff? Because I have worked remotely for 2 years, a little over 2 years, and I've also done YouTube for like forever. So I understand working remotely, and I've also worked in an office, so I've kind of experienced both, and I've found the struggles of each. So I have a lot of insight on how to manage your time and how to best survive either working from home or working in an office. From personal experience, I believe I'm better at working from home, but that doesn't mean I can't survive in an office. I've just had some problems working in an office that I will talk to you guys generally about. Like, I'm not going to give you the specifics, but some problems that I've encountered, I'm guaranteeing that you are probably going to encounter in your software development career. So if you are looking for a job that is very challenging but also very fulfilling and it pays really well, computer science is the way to go. Computer science, software programming, whatever. If you go into computer science, you might be doing some more sciencey stuff, I guess. I don't know, but basically you're going to end up with the same job. to put it bluntly, I guess. Most computer scientists will graduate with a bachelor's in computer science and then get a job as a .NET developer or a Java developer. And then they'll stay there for the rest of their life and not really do anything with compiler optimization or computer graphics or vision or machine learning or algorithms. the majority of people who graduate from a computer science program, I'm guessing, end up in the same kind of job as a software developer, someone who either picks it up on their own, goes through a camp, or goes into a bachelor's or associate's program specific to software engineering or software development. We are going to probably talk in future chats about the difference between going to school, or the difference between self-training and the difference between getting certifications, what you should do, what you shouldn't do, all of that good stuff, because that's super, super important, and a lot of stuff I've been wondering myself. Like I questioned, hey, should I go back to school or should I just jump into the workforce? And I've watched a lot of people on YouTube, and I think there is an a lot of people on YouTube represent the minority of what most software developers are. At least that's what I believe. That's what I've found. So you might not be getting the best advice from watching YouTube videos, because most people on YouTube are very ambitious. They're making YouTube videos for basically free, just to get either their name out there to teach people or to build a resume. And a lot of these people will, because they're making these tutorials, have some kind of skill that they feel they are capable of sharing with the world. And because of that, they have a high possibility of getting remote jobs, or jobs even if they don't have a degree. But it doesn't work the same for every single person. So you also have to consider where you're getting this advice. So if you're considering where to go to school, or whether you should go to school, or if you should just jump into the workforce, I believe I can give you some insight, non-biased insight, as to which one would be better for certain circumstances. So if that's a situation you are in, I ask that you would send me a message on Facebook or on here in the comments, and that will kind of allow me to prepare for your specific situation. And it's different for everybody, so it's not a yes or no answer. So that's something I'm just going to give some general points of why you would want to do one and why you would want to do the other. Like, should you go to code camps? Should you just pick up books? Should you watch videos? Should you watch Caleb the Video Maker 2? Heck yeah, you should! Caleb the Video Maker 2! Talk about pride, man. Okay. That is all for my blabberings. So I am going to answer a couple of questions, and then I'm going to go to bed, because I got to get up and do some linear algebra. Yeah! Vectors and eigenvalues! Okay. So give me some time. This part's probably the boring part of the stream, because I got to look through stuff, and you're just going to have to deal with it. Okay. Oh, got a lot of comments. Wow, cool. What's up? Been following you. Hey, hi. Hey, Caleb. Watching your videos on DB clustering. Is there any certification for DB clustering, or just the DBA certification would cover it? I honestly don't know. I will have to get back to you on that. Like, if you're talking about certifications, different database systems have certifications. So DB2 has a certification. SQL Server has a certification. So I don't know if there's a general database clustering certification. There might be one out there, but the question is it valuable? Another topic for another day. I would say a more popular certification system, like from DB2 or IBM themselves, or from Microsoft. If you're doing SQL Server, you can get an MCSA or MCSE or whatever. That might be a little bit more valuable. I have a friend who's gotten a certification. It's in an IT field, so you might chat about that someday. But definitely something we need to talk about. Okay. The next question. Hopefully that answered your question. I know I didn't really give you an answer, but I would look into studying for the DB2 certification. And regardless of whether you get a certification, certifications make a great plan of study. And that's the motivating factor for getting certifications, not the certification itself. Okay? Don't go get a certification just for getting a certification. Go get a certification so you learn the material required to get the certification. And then the certification doesn't really matter. I think certifications have a great guideline on what to study. So if you go look up a certification, there'll often be a description and say like, oh, here are some things you need to learn. Here's a study guide. Hey, here's some training videos. Going through that stuff can prepare you for the workforce if you're looking. And if you have a job, that's a great way to up your resume to make you a higher valuable employee. And sometimes employers will even pay for these certifications. So I don't think certifications are bad. Some people say, oh, all certifications, you're wasting your money, and if you get a certification, you're stupid. That's nonsense. Okay, next question. Machine learning or cybersecurity? Which major or certificate would be more profitable, and where do you suggest someone get it from? Oh, good question. Yeah, I have no idea. Sorry. Okay, moving on. No, I'm just kidding. I'll give you some insight. Okay, so I'm not a huge fan with cybersecurity. I would say machine learning is more profitable if you are good at math and good at hard things. If you are not good at math or doing complicated hard things, then I would suggest cybersecurity, because I'm pretty sure machine learning is like one of the hardest topics to learn. And as a result, it's one of the highest paying. Yeah, so hopefully that answers your question. If not, just leave a comment, and by the time I get to the bottom, I'll probably see it. How many years of experience do you have? Okay, well, I started learning about computers in high school. I don't know how many years ago that was, but, you know, I read my first HTML book with my friend sophomore year, I think. And it was like the most boring thing ever. But then I picked up a Java book, and that was actually pretty cool. But it was way over my head, so I got rid of that one. And I picked up a C++ book, and that was like the Java book times 1,000. So I didn't get anything from that either. And then I played Minecraft, and I thought I wanted to set up a private server, and that kind of led me to a book that I actually understood and enjoyed, which led me to another book about website development using PHP and MySQL, and neither of which I really use anymore. So I kind of wish I started with something a little different, but you know, the way you start is always unique, of course. So I don't know, maybe 6 years minus time in between those 6 years where I was doing other stuff or just experimenting or exploring what I was really, really interested in. Like, for example, I mentioned that one of the programming languages that I'm really familiar with is C#. Well, I didn't really get into that until like 2.5 years ago or 3 years ago or something, maybe 2 or 3 years. So it's hard to answer how much experience do you have, because I've done so many different things for short periods of time. So I've tinkered with PHP, MySQL, I've tinkered with SQL Server, Oracle, I've tinkered with DB2, I've tinkered with C#, C, C++, Python, you know, JavaScript, web development, app development, Xamarin. Like, you can't be an expert in all of those. So how much practical experience as a person, I don't personally feel like I can be like, yeah, bro, got like 6 years of experience, back up. Because the reality is, you know, I might have a half a year of experience in a lot of things. C# though is what I probably say I would have. Well, I would say I have a good, solid experience in, and also database design, and yeah, that's basically it. Hi Caleb, I'm your biggest fan. Well, thank you, Kevin. Message retracted. Well, thank you, Badridine. Not very good with names. Is Python as suitable for web development as PHP? Absolutely, it is. So go ahead and pick it up. And Python, I don't really like Python, but that's because my experience of learning it was probably bad. And now if I went back and learned it, I'd probably really enjoy it. It has a lot of uses and is becoming much more popular with machine learning and all that good stuff. So Python could actually serve you as a multi-purpose programming language, which is pretty sick. That's one of the reasons I tried to study C# so much, because you can use it to make apps through Xamarin for iPhone, Android, Windows, and you can also make web forms or MVC or whatever. You can make apps for the desktop. You can make all kinds of stuff with it. So that's something that I look for, is like, I want to learn something that's going to have lasting value. So one thing that kind of annoys me is like all the new JavaScript frameworks, like they come and go like every 2 minutes, and nobody really is finding the fundamentals in the JavaScript, including me. I did Angular for like a couple months. I didn't learn a thing about JavaScript, and now there's a new version of Angular out, and I lost all those skills. So I think Python would be a great way to go. Yeah, I have a video in my C programming series. It's called, I think it's number 37, loosely typed versus strictly typed languages or something like that. I'd highly recommend you go watch that, because that's going to put a perspective on how Python works with data types, and how that's different than C or C# or Java. It's just a different language, a lot different. What do you think about Agile? I talked about that. Oh, thanks, Carl, for pointing out my potato can. Well, yeah, it's a potato can. I'm sorry. Okay, Othman, I don't know. Hi, bro. I always get this error when I try to save my DB. Some errors have been deleted on the server. Please look at the bottom of this window. Yeah, I'm not really sure what you mean. I'm sorry. But if someone's out there watching who is super good at fixing stuff, please reach out to me, because I literally get like errors and stuff sent to me on a regular basis, sometimes a couple times a day, and I literally can't keep up with it. So I'm looking for a company that I could refer people to and maybe make some commission off of it to grow this business and help my customers, because people are sending me these huge messages with like 200 lines of code and like 4,000 errors, and they're like, hey, this needs to be fixed by the end of the day, please help. And I understand that like you need help, and I like helping people, so if it's a simple question, I usually like to help. But I'm overburdened by the pressure to respond to all of the messages, specifically ones when it comes to very specific problems. If I was building the application with you and I got that error, I might be able to help walk you through it. But it's not easy to look at a huge program and just magically know what's wrong with it. Maybe something that we need to add to this channel is some talk on proper debugging skills, because that's something that I personally want to grow my abilities in, because that's one of the frustrations I have with computer science or programming is I get these errors, and I just feel like I can't get past them for the longest time. So I would like to improve my debugging skills. What's your favorite pastime? Salvation, marriage. Hi, bro. I always get this. Oh, I already read that one. These are all like out of order and stuff. It's weird. Hi, Caleb. I've learned a thing or two from your videos in the past. Thank you. You are welcome. just some dude. You're not just some dude, you're important. Oh, nice, your company bought you a standing desk, which helps a lot to switch back and forth. Yeah, standing desks. So one thing, if this live streaming thing takes off, is I want to start this fundraiser, because basically, in other words, I don't have money, right? So I'm going to ask you guys for money, but we'll get into that another day. But I want to start this crazy fundraiser to build a sick studio. So if you guys are already sick of this potato cam and this potato mic, then let's talk about that, because Patreon and stuff is great, but just to buy some streaming equipment from like a small Blackmagic HD thingamajig, it's like $650, which is a lot. Even with my sponsorships, that's asking a lot when my YouTube income is not a lot. So we'll talk about that in the future, but yeah, something with a standing desk would be pretty sweet, because I deal with back pain from some severe health issues that I've had, and I've gotten a lot better, but it's always a continual problem. So that's why in my videos I'm always so like moving all over the place, because I just cannot sit in one spot for more than like 5 seconds, or it becomes very unbearably uncomfortable. So it's basically impossible to fall asleep because I'm moving every 3 seconds. Okay, what else? Thanks a lot for the Signal R tutorials. It helped me a lot. That is great. When I first made that series, this is an interesting thing that I wanted to share with you guys. I got some hate comments because some people were like, bro, your channel is dying. Like, oh, why are you making Signal R? Blah, blah, blah. And the reason I made Signal R is because I thought it was cool, and it is, and I was using it at work. So, you know, it was easier for me to learn the material because at work I was using it. So it's kind of trying to optimize my time. And that was something that actually kind of discouraged me for a bit, because like I was kind of lost on what to do, and I don't think Signal R is what I'm meant to do for with my life and with my YouTube channel. But just the fact that I enjoyed it is enough for me. And since then, I've had extreme positive feedback on that series from numerous people like you who weren't able to find the resources to learn Signal R on the internet. And I gave them that resource, and that means a lot to them. So all them haters, just gonna keep hating, but I can do what I want because I have an audience who actually cares. That's what's awesome about the people here watching and the people who are subscribed and support this channel. If I made a video of something that's not necessarily revolutionary or popular, I still get the support because I'm still helping the community, and that's what's awesome. Oh, wow, lots of questions about certification. Zend PHP certification. I actually don't know about that one, but this is great because I know you guys are obviously interested in certifications, so I'll have to do some more research. So let me write that down. Dude, oh no, just some dude. In my experience, and also from talking to employers, though, they really care about what you've done and not at all about what degree you have. Yeah, I've had that same experience. I've actually had the problem where I am in school and I'm having more of a problem getting a job because they want someone full-time or whatever. And I have enough experience with this YouTube channel and with the jobs I've had that they want me, and school is actually getting in the way. That being said, I still think the pros in my situation outweigh the cons because I'm not in a huge rush to go get a job. So that's fine. And also I have the experience. So, yeah, you have some good insight. We'll have to get into that more. I'd like to talk about that. So Let me write that down as a potential stream idea. College and whether it's a big fat waste of money and if you should do it or should you not do it. Good question. There's some really good reasons why I decided to go to college that most people probably don't think about. So I would absolutely love to share those with you guys. Oh goodness. Bayrava. Hello, he was a great teacher. I can understand his tutorial very well. Thank you, sir. And then someone corrected him. He is a great teacher. Well, thank you. Thank you guys for the support. I am not a genius, though, by any means, shape, or form. Not even close. Trust me, I know geniuses. Super good point about certifications. Can you do networking videos? I really like you, by the way. Maybe some networking videos. Not my expertise. I'm more on the software, so maybe I could do something like how do you use different internet protocols through a programming language, for example, or how do you communicate to software through the network. That would be something I would consider doing, but I'm not really interested in like making the videos on the network topologies and all that junk, because that is more IT, and I would rather focus my resources on some other topics that I've been wanting to record on here. So we will see with that, but as of now, I'm not really feeling like the networking as a whole, but more like with programming. Are you planning to make videos on MongoDB as well? How funny you should ask, my friend. There is a MongoDB video on my channel right now. That video has been up for about a week or so, and it's about 20 minutes, so it'll give you a great introduction on MongoDB. Just go on my channel, search for it, and you should be good. And if it goes really well, I might consider making some more MongoDB videos. But right now, I'm pretty convinced that DB2 is the best offering out there, and they offer unstructured data just like MongoDB. So what's the benefit of using MongoDB? Not very much. Someone asking about like who I am, what do I do, what do I like, all that stuff. Yeah, I'd say my work history and personal history or whatever probably will save for yet another talk, because I could probably give a big explanation on who I am, how I got here, and how I got into programming and why I think it's the stinking awesomest thing in the world, second to a couple other things. Okay, so let's write that down. About my career. Probably focus it on my career because, yeah, that's what we're talking about here. So, how about Laravel? I don't know how it's pronounced. I think that's a PHP framework. I'm done with PHP tutorials for now, anyways. So, probably not going to happen. Sorry. That's all for the live comments. I am going to go for some other comments if you guys have any, so post them now. Okay, so I do have some comments from other people that have sent me messages, and this is one of the great things of why I wanted to do a live stream, is because I can help these people and help you guys at the same time and save me a lot of time, because if I spend, you know, an hour or two a day replying to comments, well, I'm only helping like one person. And yeah, one person is super important in my eyes, but that's less time I have to, you know, like live my life and like eat food and chill on the beach like I do every day. No, I'm kidding. I have to have more time to make these videos. Okay, so Bayrava, I cannot pronounce names, so I'm just gonna probably slaughter them all, but I think I should say names to make it A little more personal. Will I make advanced C tutorials? Maybe, actually. So C programming is one of the foundational languages, and I think it is a good thing to know. It's not really like my expertise, but I have made some intro C tutorials, and I am planning on finishing my C programming tutorial series. So that I have the whole thing planned out, so all I literally got to do is record it, edit it, upload it, write descriptions, write transcript. I don't think I'm going to write transcriptions. Put it on my website. So I'm going to still have a ton of work, but all of the time invested in planning that series, I don't want that to go to waste, because I could literally no life record these things for a couple days or a week and get the whole series finished. Should be about 100 videos, and that's not going to go into advanced C programming, but like at all. But it will go into some of the intermediate concepts with pointers and maybe memory allocation, but I'm not sure like how much I go into that. So if that series goes well, that's my test run. The 100 videos is my test run. If it goes well, I will consider making an advanced C programming series. But that's an if. Next question, Elenam. This person wants me to create a website, a page on a website. Oh, he wants to create a page on a website so students can access their certificates and testimonials or documents using a PIN code. But he has no idea how to do this, and he wants me to help out. Well, I can help out through this live stream. I can give you a rough idea of how to get started. Essentially what you're trying to do is form validation, just in a more complex way. So research form validation. Essentially what form validation is making sure people don't put in malicious stuff into your forms to break stuff. And you're probably wondering, well, what does that have to do with anything? Well, if you can check form data for that, you can validate it for other stuff. So you can validate if they're putting in the correct PIN code, for example. I know that's kind of vague, but just pick up some language, follow a series on form validation, and you might just get where you're trying to go. Once you can validate if the access code they're typing in is equal to the access code in the database or in hard-coded in the code, at that point you could potentially make this application. My camera seems a little laggy, so let me know if this stream is falling apart. The date of the internet here is really fast, but it's very flaky. It goes on and off. Babaram. Next question. I started learning HTML, CSS about a month ago. Problem with the color code in HTML. Okay, so I think I understand what you're saying. If I get it wrong, I'm sorry. But I can share with you the trick to understanding the color code. So I think what you're talking about is if you set some color code in CSS, it looks something like #17243F, for example. And you are asking, what is the system behind this code, right? How do you know what code is going to produce what color? Or how do you know if you have a color about what code it is? Well, sorry, I'm stretching my elbow. It's kind of like, it's like I'm showing you something, but just stretching. When you get into some, sorry, I gotta remember that the microphone is like down here and I keep like banging, so if it's really super loud, I apologize. I'll try to upgrade my mic here soon. I do have another mic, but I use it for my tutorials, and I don't want to have to like lug it back and forth. So this Logitech C9 potato microphone is all you're gonna get for right now. What was I saying? Oh yeah, the CSS color codes. How do you understand them? Well, if you get into some complex colors, it's kind of complicated. because it's complicated. Because it's hard to mix colors in your brain and know what it's going to make. But when you're talking about one individual color, it's pretty easy. So the 6-digit code is the first two, well, after the pound, the little hash symbol, there's 3 groups of 2. The first one is red, the second one is green, and the third one is blue. So red, green, blue. Okay, now how do you make colors out of that? Well, if you just take red for example, 2 digits essentially, 2 characters. That is actually in hexadecimal, which is 16 characters. So it's not technically a digit because a digit is implying 10, but there's 16. So we have 0 through 15 represented through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, not 11, A, B, C, D, E, and F. Okay, so I can't give you a whole tutorial on how to convert decimal to hexadecimal right now because I would probably need something other than an Irish whiskey advertisement, which I've never drank in my entire life, so I don't know why I'm sitting here, but that's okay, I guess. I showed that to my mom. I'm getting off topic. Anyways, once you know the hexadecimal conversion system a little bit, you can kind of understand. The basics, though, is the numbers are lower, the letters are higher. So if you have FF, that is like the highest amount of red. If you have 0, 0, that's the lowest amount of red. If you have 2, 4, that's like a little bit of red. If you have AD, that's like a lot of red, but not all the way full red. And then you can do that for the next color. So add a little bit of blue and then add a little bit of green. And once you mix all those together, you get a color. So that's how that works. There's a total, if you convert it to decimal, each section of 2, each one goes up to 255. So if you think about it in decimal, 0 would be the lowest. 255 would be full out red. If you do all of them the same, something interesting happens. If you go 0, 0, 0, 0, 0, 0, 0, I think it's black, right? 0, 0, 0, 0, 0, 0, it's black. If you go 1, 1, 1, 1, 1, 1, it's really dark, and you can keep doing that all together all the way up to FF, 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 which will be white. So if you balance them, you get shades of gray. And if you guys have no idea what I'm talking about, I apologize. It's kind of hard to answer a question without if you don't know CSS and HTML, you're probably what is this dude talking about, son? And I'm all blabbering about numbers and junk. So just ignore me. But yeah, that's the basics of understanding color codes inside of CSS. So to pick colors, you use that. And also there's another shortcut if you just want copies of 2. So if you want to let's say you wanted pound 112233, well, you could shorten that to pound 123. It's a little trick. You can also just look up hexadecimal color picker online, and then you can pick a color and it'll give you the code, and then you take that, copy it, and paste it into your CSS, and shablam, boom, there you go, you got the color you need. If you do, oh yeah, that's all I'm going to say. So let's move on to the next question. Amen. Amen, I'm guessing is how it's pronounced, is the next questioner. So can you do some videos about CMS? Okay, so CMS is short for Content Management System. And basically it's a fancy way to build a website without actually knowing how to do anything, or knowing how to do very little. So some of the most common CMSs are WordPress, Joomla, all that good stuff, which I would recommend both of those. There's also Drupal, and there's Umbraca or whatever, which is C# based. There's a bunch of them out there. So one thing I did want to mention is that I do have a hosting company that I promote. I'm starting to promote anyways because I've used them since I've started my websites and I've had the most wonderful experience with them. So if you are looking to get a content management system so you can build a website without having to code every single little detail, I would highly, highly, highly recommend this host. And I'm going to give you guys a link so that if you do want to get some web hosting and you sign up through this link, you'll actually be helping me because they give commission and they give extremely high commission. So if you buy a year of hosting, which that would be the best value for both of us, if you buy a year of hosting, I am getting almost the full first year of hosting to my account, and then after that they get all of it. But that would be a great way to help support me. So let me find that for you guys. But I run multiple websites off of their hosting, and it's been nothing but good. The reason I like them so much is mainly because of support. They support me really well, and they do like a live chat. If it's urgent, you can do a live chat. So I'm going to get you guys a bit.ly so that way it's super easy. Or actually, I'll get you a different code. It's yeah, just give me a minute. So I've had issues where I think some plugins that I had installed with what's it called, WordPress, had some security issues, and they notified me. They said, hey, we found these issues, these files have been changed, or like there's potential that these files have been changed. We've done what we can do. Here's what you need to do. And they were able to guide me through the process, and they do a lot of great stuff. And it's not GoDaddy, because I don't like GoDaddy. Just throwing that out there. So I will give you guys this link in about 13.5 seconds. Okay, I'm going to take this and I'm going to paste that into the chat for you guys if you are interested in it. And the company is DreamHost. So if you go to bit.ly/ctvm2 DreamHost, that will take you to their website where you can sign up. I'm totally getting off topic. I should have had that prepared, so apologies for that. I'm almost done here. I got about one more question. But one thing with DreamHost, the reason I brought it up is not just to advertise. They actually have one-click installs, basically, like for Joomla and also WordPress. So you can set up a website with a custom domain super easy, which is great if you're trying to start like a portfolio. You can easily make websites for customers and make some money without having to really know a whole lot. And as you learn, you can start customizing or whatever. Jamie asks, do you ever help college students? I have an online course and the professor is no help. Unfortunately, I get this comment like every day. So apparently there's a lot of bad professors out there. Either that or you're sleeping in class. Jamie, you better stop it. Better get some sleep before you go to bed. No, you better get some sleep before you go to school. Do I ever help college students? Yes, I do, but not very often, because typically helping college students means, hey, I have this homework assignment. Can you do it for me? There's particular situations I'm thinking of where someone commented or messaged me and said, hey, here's this final project that's due tonight. Can you help me finish it? I'm like, no, I can't help you finish this. So he proceeds to cuss me out and say I'm worthless and that basically I should stop living, whatever, I don't know. So generally, no, I don't help, but if it's something conceptual, I'd love to talk about it in these things. So go ahead and share what you got, and I'll see what I got and see if I can help. Yeah. Let me see if there's anything else I wanted to say before I go. All right, that's all the questions I have from messages. I'm just going to see if you guys put any other messages before I go. Someone mentioned making advanced tutorials for those who don't go to colleges. Yeah, that's something that I want to do here. I don't just want to scratch the surface. That's not going to help you guys with anything. I like to go in for some depth. All right, it seems like that is all of the questions I got for today. Let me know how you guys liked my first really full 2-hour stream. Oh yeah, feels good. Like yesterday's was 15 minutes and I felt completely unfulfilled because I wanted to do it for much longer, and I still kind of want to do it more, but I have nothing else to talk about. So your guys' responsibility is to get some questions sent to me. Anything. Send them to me. Place them in the comments. Probably do it on the published video, so that way they're on there and I can find them for the next stream. And as always, it's my first one. I'm saying it like I've been doing it for years. Check out the upcoming live streams. And please support me by subscribing, and I would highly encourage you to go check out IBM DB2 database, because they are giving me some tremendous help to get this content out and supporting me financially. So that's a blessing to both me, to them, and to you. So it's a win-win for all of us. So that's really awesome. Yeah, that's all basically I got in this video. So thank you, and I'll see you in the next one. I'm still working on a schedule, so I don't know exactly when I'm going to be doing these. So we shall see. We shall see. Yep. Well, I'm going to have some more news for you guys next time, and I will see you later.